In this video, I'll show you how to build a single shared camera system in Unreal Engine 5 that will keep all your players perfectly in frame. For this demo, I will be using the third-person template. We do not need the split screen, so let's disable it. In order to test our camera, we need multiple players to exist in our level. So let's add these two nodes in order for us to test this. Don't forget to save and compile. Now when we press our debug key, we should see the new players being spawned. If you are using the 5.6 version of the engine, you may find these errors. We can fix this very easily just by clicking here and changing the begin play to the onPossess event. This error happens because we're trying to set up the input of a pawn that doesn't exist yet. Because whenever we're adding a character, the controller is getting added first, so that begin play event runs first, and the target is not being found. To avoid spawning the players in the same place, let me add more player starts to my level. Something that we need to take in consideration is that whenever we create a character inside Unreal, each local player receives an index that starts from 0. An Unreal Engine will use the first player as the default camera. To have more control over the result, let me create my camera actor blueprint. Let's choose an actor. Let's open it, and inside it, let's add the needed components. Let's search for the spring arm component, which will be used to hold the camera. Now let's change the target arm length. Let's also remove the collision test of the spring arm. We don't want any character to block our camera. Now let's rotate the spring arm a little bit to get the angle that we want. Finally, let's just add the camera. And the only thing we need to do with the camera is reset the rotation value. Let's save and compile and see how our camera looks in the level. Now we know that our camera works, but we shouldn't drag and drop the camera to our level every time we want to use it. Let's delete the camera that we added and create a camera manager actor, which you can find here in all classes. The camera manager class is going to help us set up our shared camera. This class is a part of what is known as the gameplay framework of Unreal Engine, and I would suggest to check out more information about it in the Unreal documentation. Let's go to the event graph. Here, we need to create the camera that we're going to be using during the game, so we need to spawn it. And let's just give it a spawn location of 000. Now let's promote the spawn actor to a variable. That way we're going to be able to make changes later on by just using this variable name. With the shared camera created, we need to use it. So we need to get the controller and give it the point of view of our new camera. Here we could connect it like this, but let me just get a new variable of the same kind, just so the wires don't cross each other. Let me remove these disabled events. And now, in order to not spawn this camera multiple times, because I only want one instance of it in the level, we're going to check if our local player is the first player, which would mean that the index would be 0. To achieve this, we're going to use a branch node, and what this branch node will be checking is the comparison between our ID and 0. If it is 0, then we know that this is the first local player. We do need to do something about this begin play, because we're going to run into the same problem we were having at the start, where our controller is trying to do things, but it still hasn't possessed anything. So I'm creating this custom event so we can call it later on. With our details panel docked to the sidebar, it will be easier to get the whole picture of our blueprint. Also, don't forget to save and compile. Let's now use the camera manager that we just created. To find which controller we are using, let's just go here and edit the one that is being used right now. We will find in the class defaults that we can set up the camera manager here. Now, the last thing we need to do in this controller blueprint is actually set up the camera, which is the custom event that we created inside the camera manager. To do this, we just need a reference to the camera manager, cast it to our own class of camera manager, and then just call the event that we created. We are connecting this new logic at the end of the sequence just so we don't mess something in the template. And as always, don't forget to save and compile. Now, when we press play, we should have an static camera that doesn't move whenever our player moves. And whenever a player gets added, we will still have one camera. Now let's position this camera correctly. Before continuing, let's remember that this free tutorial is sponsored by us. If you want to improve your game development skills, make sure to check out our on-demand courses for free. You can watch them and get high quality free education. And if you're a serious game developer, make sure to check out our UNF game development program, where you will create a game from scratch and publish it on Steam. To find the correct location is all about deciding the framing that we want for our camera. If we only have one player, we want our camera to be positioned on top of it. So what happens if we have two players? In this case, we just need to find a middle point between the two players and position the camera there. This will be the same thing that will happen with 3 players or with 4. The math is very simple. Let's go with the easiest example. Here we have 2 locations and 1 axis. In this x-axis, we have these units. And let's say we're positioning these 2 locations in these 2 values. To get the middle point, you just add the 2 values and then divide them by the number of values that you have added. This is the logic that we will be using for our camera. Just remember that we also need to take in consideration the other axis. And it won't matter how many players we have in our game. And this is what we're gonna do now in the engine. Let's go to the shared camera and update the location of our camera depending on the players that we have in game. The first thing we need to know is how many players are right now in the game. The class inside Unreal that knows this information is the game mode. So by getting a reference to it and using this function, we can get the number of players our current game has. Then I will create a variable called location_sum, and this will be a vector variable. We are going to use this variable to add all the players' locations inside of it, and then dividing it by the number of players to get an average location that will be the center point of all my players. To do the sum of the locations of all my players, I'm going to use a for loop. And to know how many times this loop should go for, I'm going to subtract 1 to my number of players. This is done because the for loop is starting at the index 0. If I just connected the total number of players directly, let's say that we have 4 players, then that would mean that it would run 5 times. The next thing we need to do is actually add the locations of each player, and then save it in this variable. What we need to do is add the value that this variable currently has to the location that my player have. I will use the node getPlayerPound and pass it the current index. This node will return the pound that is linked to this index. From here, we just need to get the actor location and add it to my addition node. As a side note, I'm not worried about adding a for loop inside my tick event because the maximum amount of local players that a real can have is 4. The last thing we need to do whenever this for loop finishes is set the location of this actor. So let's get our variable and divide it by the number of players that currently exist in my game. Let's change this pin, so instead of taking a vector, it will take an integer. After making the connection, let me use reroute nodes to tidy things up a bit. Just double click on top of a wire and you will create one easily. You can also use the Q key to straighten the connections of the selected nodes. Now let me get rid of unnecessary disabled nodes. Let's save and compile and test what we did. Here, our camera should follow our character, and whenever a new player gets added, it should take that in consideration. So good job. It should be working correctly. Now, the only issue right now is that if I go out of the bounds of my camera, I lose sight of my character. And that's not good. Let's go back to the camera and add a way to frame all the characters in our level. To do that, we're gonna change our spring arm length. And we're going to use a bigger value when at least one of the characters is far away from the center point. So first we need to determine what's the biggest distance from the center point. We need this value to be a float one. And now we just need to determine which distance is the biggest one by using a for loop, going through each of the characters and checking their location against the center point location. We are going to be using the same nodes to get all the players, and that way we can get their locations. We just need to add a branch node so we can determine which distance is the biggest one. So let's get the player, let's get its actor location, and compare it with the actor location of this blueprint. We will be using the distance node, which takes two vectors and return the distance in a float value. Then it's just a matter of comparing which one is greater, if the new distance or the old one, and if it's true that the new distance is greater than the old one, then we just save it in our variable. And that's pretty much it. Then we just need to organize a little bit our nodes. With this value, now we are able to get the spring arm and change the length of the arm. With those connections, we now just need to actually set the target arm length. And before we do anything, I'm gonna create a variable that will hold the base value of my arm length. So after compiling, I'm going to set up the value. I'm doing this because later on we're gonna multiply this value by our zoom value. Before doing that, we need to transform this value that we have, that is the actual maximum distance that we have got right now. And to achieve this, we're gonna use the map range clamped node. As an input, we just need to define the values that we expect. And then the result, we're gonna multiply it by my arm length. So that's how we're going to transform this base arm length. So again, the inputs will be the values that I'm expecting to have, and the out range will be the zoom value that I will assign to it. So in this case, 1 and 1.5. I got these values by testing the game and seeing what fit best, but it will be a good idea to replace these magic numbers to actual variables. So let's promote each one and assign it a name. Now let's try it and see how this is looking. Whenever we add a player, we can actually test if the manipulation of the target arm length is actually working. And it is working. The only problem would be whenever I go too far from the screen. Right now, nothing is preventing me to go out of bounds and break the camera. So let's fix that and call it a day. we will add this check inside the blueprint of our character. Search for the move function and double click on it. Here, the first thing is getting a reference to our camera. We cannot get it from the camera manager because each character will have its own camera manager, but not all camera managers creates a shared camera. We need to search for our shared camera and promote it to a variable so it's easy to access it. Give it a good name, and let's make sure that we are only calling this once. That's why I'm going to add the check if this is valid or not. If it's already set up, then I won't worry about it. This next part is solving a problem that we already had, which is whenever we hold one key to move and then we move the mouse, we will see that our character is moving everywhere. So that's not what we want. We will get the camera, our shared camera, and get the rotation of it. Here, we want the world rotation of the camera component. And with this rotation, we will want to replace that control rotation node. So we just need to hook it up to the same pins. And let's do the same thing for the other side. Now, when we test the project, it won't matter where our mouse moves. And even better, if we rotate our camera for some reason, let's say we add a 45 angle here, then it still works correctly because it's based on the rotation of the camera. So after undoing the changes, let's go back to our character blueprint and add the actual code to make it so we don't move whenever we reach the bound of our camera. The first thing we need to do is use this select node to select which value to pass. This will depend on that boolean variable there. So if something doesn't satisfy our boolean, it will send a zero value. The first check will be if we are too far away from our middle point of our camera. To get the distance, we can just subtract both vectors. This result, we need to put it in terms of our camera. So we just need to project it onto the camera x axis. To do that, we just need to get the right vector of our camera and then do a dot product between both vectors. To explain this math part, I believe it will be easier if we just do it graphically. The dot product is just a projection. So if I have a vector here, we can think as flying arrows which have a direction and a certain length, which we will call magnitude. If we have two of them, the only thing that will happen is this. Depending on what vector you put first in the dot product, then we're going to project it, and then we will have something like this. In regards to the order, it really doesn't matter. It's a lot easier if we think of these vectors as being in the same axis. So let's say my camera vector is just 1. So let's just put these two numbers. And my camera goes from 0 to 1. This is what you call a unit vector because the length is 1. So if my camera vector is 1 and my other vector, let's say it's 3, then when we project it, the answer is very clear. It will be 3. The result that the dot product will give me, if they are going in the same direction, will be a positive value. But if they are going in different directions, then I will receive a negative value. Equipped with that knowledge, we need to use the absolute node so we can compare the same value. Otherwise, sometimes this dot product will give me a negative value. And for now, we will use this test value to do this check. Now let's arrange the nodes a little bit and do a quick test of what we have done. In this test, we will notice that we can reach the edge, but immediately get stuck in it. So to fix it, we will need some extra conditions. So we will be adding an OR, because if my dot product is positive and also my input is positive, then I do want my character to be able to move. This part is sped up because I made a mistake. That operator should be greater instead of less. Don't worry, I'll fix it in a second. But this AND operator, this one, I do really need it. And I do need to connect it like this. Let's fix the error by deleting the node and adding a greater one. Let's connect it to the AND node. And now let's test it. Now, when we reach the edge in one side, it will let me return. But if I reach it on the other side, I will get stuck. I will need to add the same logic, but for the other side. Because this is a function, we can replace these long cables by just getting the actual value directly. Now let's add the same code, but for the other side. And in this case, we need the less operator in both cases, for the dot product result and for my axis value. We will need another AND node, and we just need to connect it like this. And in the case of these two Boolean results, we just need to get an OR value, because it will always be one or the other. And that's pretty much it for the x-axis. It should be working now, so let's test it. And yeah, it's working that way, and it's working to the other side. We just need to do it on the y-axis also, so the movement can actually be limited by the camera. So let's just copy and paste everything, and we will make some changes. First, we no longer need the right vector. Instead, we're gonna use the up vector. Now let's connect the result to the dot product. And then let's change, instead of using the x-axis, let's use the y-axis. Let's replace the connections and put our new values to use. If we test it now, then it will start working in every direction. And the only thing left to do will be to tweak the actual value of the distance we want to use. For that, let's just use the value that exists inside the camera, which is the max distance value. We're organizing the nodes a little bit. Let's do the same thing for the other side. And I just copied and pasted the nodes that we were using before. And again, let me organize the nodes a little bit. Now, when I test this, there was one thing that was bothering me, and it has to do with the vertical bounds and the horizontal bounds. For the vertical bounds, you will see that you have a lot of space to walk in, but in the horizontal ones, I get stuck right there. So I will boost a little bit of that value, and here is just a matter of multiplying any number, really, whatever feels right to you, to this distance, and then you're pretty much done with it. So yeah, after doing that, it's just a matter of testing, see if we can go a little bit farther on the sides and the normal amount in the upper bound and the lower bound of my camera. And yeah, I like this result more than the previous one. So there you have it, a fully functional local multiplayer shared camera. If you found this helpful, give it a like, subscribe, become a member, and I will see you in the next video.